On May 4, 2019, Union Pacific Big Boy number 4014 moved under its own power for the first time in 60 years. Not in a museum, not on a short demonstration track, on the main line. The same main line it had operated on when it was pulling 3,600-ton freight trains over Sherman Hill in 1959. The last year it ran in regular service before being set aside, displayed, and left to stand motionless for 6 decades while the world around it changed beyond recognition. The sound it made when the throttle opened was not the sound of restoration. It was the sound of resurrection, a deep percussive exhaust note that the men standing on the platform at Cheyenne, Wyoming had never heard before, because every one of them had been born after the last big boy had gone silent. They knew the sound from recordings. They knew it from descriptions written by men who were now dead. What they did not know, and could not have known until that morning, was what it felt like to stand beside one when it was alive. The people who restored number 4014 spent 7 years and more than $4 million bringing it back. They disassembled a locomotive that had been sitting outdoors in Pomona, California for 54 years, exposed to sun, rain, vandalism, and the slow chemical processes that convert steel to rust and rubber to powder and gaskets to nothing. And they rebuilt it to a condition that exceeded its original specification in several respects. They replaced components that had been cannibalized by previous owners. They fabricated parts from scratch for which no supplier existed because the industry that had made them had ceased to exist decades earlier. They solved problems that no manual addressed because the men who had understood these machines had retired or died before the restoration began. What they produced in May 2019 was not a replica and not a static display. It was a functional steam locomotive, a machine that could pull a passenger excursion train across Wyoming at track speed, that required a licensed engineer and a trained crew to operate, that consumed coal and water at rates that made every run a logistical operation, and that generated, in the communities it passed through, a response that no diesel locomotive has ever produced. How a machine dead for 60 years was brought back to life is a story about engineering, but it is also a story about institutional memory, about the particular difficulty of reconstructing knowledge that was never written down, that existed only in the hands and minds of men who learned by doing, and who, by the time the restoration began, were no longer available to teach what they knew. To understand what number 4014's restoration required, the condition it was in when Union Pacific's mechanical department began their assessment in 2013, must be understood without the softening that nostalgia tends to apply to old machines. The locomotive had been donated to the city of Pomona, California in 1962, 3 years after its retirement from revenue service. It had been placed on static display in a public park, accessible to the public, exposed to the elements, and maintained, to the extent it was maintained at all, by the city's parks department, rather than by anyone with knowledge of steam locomotive operation or preservation. Over 54 years, the Pomona climate, hot, dry summers and mild winters, with occasional heavy rain, had worked on the machine in the specific way that outdoor storage without protective treatment works on large steel structures. The boiler had not been hydrostatically tested since 1959. Hydrostatic testing. Pressurizing the boiler with water to its designed working pressure to verify the integrity of the shell, the tubes, the firebox, and all the fittings is the fundamental safety verification for a steam pressure vessel. And a boiler that has not been tested for 50 years cannot be presumed safe. The question was not whether the boiler could be tested, but what the test would find. The running gear, the side rods, the main rods, the valve gear, the driving axles and their bearings had been exposed to Pomona's weather without lubrication for 5 decades. Steel that is not lubricated in a climate that cycles between wet and dry develops surface corrosion that begins as a visible rust layer and progresses over decades to pitting that reduces the cross-sectional area of structural components below their design capacity. The rods and axles would need to be inspected, dimensionally measured, and evaluated for whether they could be refurbished to serviceable condition or whether they required replacement. The cab, the crew compartment where the engineer and fireman operated the locomotive, had been accessible to anyone who climbed up the steps during Pomona's 54 years of public display. The gauges, valves, and controls that filled the cab walls had been subjected to everything that uncontrolled public access produces: vandalism, souvenir collection, weather exposure through gaps in the weather stripping, and the gradual disappearance of small components that people found it easy to remove and difficult to return. The mechanical stoker system, which fed coal from the tender to the firebox at the rates that Big Boy's operation required, was incomplete in ways that the initial assessment could identify, but not fully characterize without disassembly. The tender, the 14-wheel vehicle coupled behind the locomotive that carried coal and water, had similar exposure history. The water tanks, which held approximately 25,000 gallons of water for a standard run, were not watertight. The coal bunker, which held approximately 56 tons of coal, retained its structural form but not its operational hardware. The mechanical connections between the tender and the locomotive, the drawbar, the steam connections, the air brake systems, were intact in form but uncertain in function. Union Pacific's mechanical department at Cheyenne, which conducted the initial assessment, produced a report that was honest about the scale of the work required. The locomotive was restorable. The fundamental structural components, the boiler shell, the frame, the driving wheels and axles were present and potentially serviceable. But restoring it to operational condition would require a level of disassembly, inspection, fabrication, and reassembly that no entity except a fully equipped steam locomotive facility could accomplish. Union Pacific had last operated steam in regular service in 1960. Its Cheyenne facility had maintained diesel and electric equipment for the 5 decades since. The institutional knowledge of steam locomotive maintenance, the procedures, the tooling, the dimensional standards, the inspection protocols existed in the facility's historical records and in the memories of retired employees, but not in the active practices of the current workforce. The restoration was, from its beginning, a recovery operation operating on 2 fronts simultaneously: the physical recovery of a specific locomotive from the effects of 54 years of outdoor storage, and the institutional recovery of knowledge about how to maintain steam equipment that the organization had allowed to lapse when it was no longer needed for daily operations. The decision to restore number 4014 was made by Union Pacific's leadership in 2013, 4 years before the work was scheduled to be complete in time for the 150th anniversary of the Transcontinental Railroad's completion, an event scheduled for 2019 that Union Pacific intended to commemorate by operating the restored Big Boy on the original route across Wyoming and Utah. The institutional rationale for the investment: more than $4 million in direct costs, plus the internal labor costs of the Cheyenne Mechanical Department staff who would spend years on the project, was not primarily historical sentiment. Union Pacific's leadership understood the locomotive as a marketing and public relations asset of a kind that no conventional corporate communication program could replicate. A functional Big Boy running on the mainline would generate media coverage, public interest, and a form of brand association between the Union Pacific name and the most dramatic expression of American industrial engineering in the railroad era that was available only if the machine actually moved. The alternative, a static display in a museum, however well curated, was not the same thing. Photographs of number 4014 sitting in Pomona's park had been available for decades. They generated historical interest, but not the emotional response that came from standing beside the locomotive when it was alive and running. The distinction mattered, and Union Pacific's leadership understood that it mattered, which is why the investment in an operational restoration, rather than a cosmetic one, was made without apparent hesitation once the project was approved. The restoration was assigned to Union Pacific's steam shop at Cheyenne, a dedicated facility established specifically to maintain the railroad's operational steam fleet, which at the time of number 4014's restoration included several other historic locomotives that Union Pacific operated on excursion and promotional assignments. The steam shop's staff had experience with 19th and early 20th century steam equipment, but the Big Boy's size, its complexity, and its specific mechanical systems represented a step beyond what the shop had previously undertaken. The project manager assigned to number 4014's restoration, Ed Dickens, had spent his career at Union Pacific maintaining and operating the railroad's historic steam equipment. He understood the practical reality of steam locomotive restoration in a way that combined technical knowledge with the institutional memory that had been accumulated over his years of working on older equipment. He also understood the specific challenge that the Big Boy's restoration presented. It was not an upgrade or a renovation. It was a resurrection, rebuilding a machine whose systems had been entirely static for 60 years, whose institutional knowledge had partially lapsed, and whose operational requirements exceeded those of any other locomotive in the railroad's historic fleet. The disassembly that began when number 4014 arrived at Cheyenne revealed what the initial assessment had anticipated and what it had not. The boiler, when examined by Union Pacific's boiler inspector and by independent certified inspectors, whose sign-off would be required before the locomotive could be operated under steam pressure, was in better condition than its outdoor exposure history suggested. The steel shell had survived without through-wall corrosion on the primary pressure-bearing surfaces. The firebox, which operates at higher temperatures and stresses than the cylindrical boiler shell, had wear and corrosion that required attention but not replacement. The flues and tubes, the hundreds of small diameter tubes through which hot combustion gases pass on their way from the firebox to the smokebox, heating the water in the boiler, were corroded and in need of replacement, which had been anticipated. The running gear presented problems that were both more severe and more varied than the initial assessment had fully captured. The side rods, the connecting rods linking the crank pins of the main driving wheels to the other driving axles, had surface corrosion that dimensional measurement revealed had progressed into the critical tolerance zones for several components. The bearings, which had not been lubricated for 50 years, were seized in ways that required careful disassembly to avoid damaging the journal surfaces they protected. The valve gear, which controls the timing and duration of steam admission and exhaust in each cylinder, had components that had corroded together and required penetrating oil, heat, and careful mechanical persuasion before they could be separated for individual inspection. The cab systems presented a different category of problem. The gauges, boiler pressure, water level, steam chest pressure, cylinder cock indicators, were not merely cosmetically damaged, but mechanically inoperable in ways that required replacement rather than restoration. Replacement meant fabrication, because the gauges that had been fitted to the Big Boy in 1941 were no longer in production. The suppliers who had made them had ceased operations decades earlier. The dimensions were documented in the original specification drawings, which Union Pacific's engineering archive held, but finding of fabricating replacements that met those dimensions while also meeting current safety standards required research, sourcing, and in some cases custom manufacturing that added time and cost to a project already operating under a fixed deadline. The mechanical stoker system, the device that moved coal from the tender to the firebox at the rates required to sustain the Big Boy's boiler output, was, when fully assessed, missing components that had been removed at some point during the Pomona storage period and not returned. A Big Boy without a functional mechanical stoker cannot be operated at full power. because the coal consumption at maximum output exceeds what a human crew can deliver manually. The stoker system had to be restored to complete the locomotive's operational capability, and restoring it required finding replacement components for parts that have been out of production for 60 years. The fabrication challenge that the missing and damaged components presented defined the character of the restoration in a way that distinguished it from automotive restoration or even from the restoration of smaller, more common steam locomotives. A steam locomotive of the big boy's size and complexity contains thousands of individual components, each of which was designed and manufactured to specific dimensional tolerances that determine whether the assembled system functions correctly. Most of these components were made by suppliers who specialized in steam locomotive hardware: valve manufacturers, bearing manufacturers, pipe fitting manufacturers, gasket suppliers, casting foundries, whose entire business model depended on the existence of a steam locomotive industry that required their products in volume. When that industry ended in the 1950s and 1960s, most of these suppliers either ceased operating or redirected their production to other markets. By 2013, the supply chain for steam locomotive components had been absent for 50 years. Some components, standard pipe fittings, fasteners, certain bearing types, could be sourced from general industrial suppliers because their specifications overlap with components used in other industries. But many of the big boy's specific components, the mechanical stoker parts, certain valve components, specific bronze fittings that had been machined to locomotive-specific dimensions, had no contemporary equivalent. The solution was fabrication, machining new components from raw material using the original specification drawings as the dimensional reference. Union Pacific's Cheyenne facility had machining capability, and the project identified additional machine shops with the capability to produce specific components that exceeded the Cheyenne shop's capacity. The drawings from Union Pacific's engineering archive provided the dimensional basis. The material specifications, the steel grades, the bronze alloys, the cast iron compositions, had to be cross-referenced against contemporary material standards to identify equivalents that met the original mechanical requirements. This cross-referencing was itself a research project. The material specifications in 1941-era drawings used designation systems that had been superseded by subsequent revisions to the relevant standards. Translating a 1941 steel specification into a current ASTM or SAE material designation required understanding the historical context of the original specification, identifying which current material most closely matched the original mechanical properties, and documenting the equivalence in a way that the regulatory inspectors overseeing the restoration would accept. The men doing this work were diesel mechanics, machinists, and engineers whose training and experience had been in the maintenance of late 20th and early 21st century equipment. They were not steam locomotive specialists. They became steam locomotive specialists in the specific area of the big boy through the process of the restoration itself, reading the original specification documents, consulting with retired Union Pacific employees and with the broader steam preservation community, and solving problems that no procedure manual addressed, because the procedure manuals had been written for a workforce that already knew the answers. The operational knowledge that the restoration required, the accumulated institutional understanding of how to run and maintain a big boy, was the hardest thing to recover, because it had existed primarily in people rather than in documents. The men who had maintained and operated the big boys in regular service retired in the 1960s and 1970s. Some had written accounts of their experiences, memoirs, technical articles, oral history interviews conducted by railway historians who had recognized the importance of capturing this knowledge before it was permanently lost. The Union Pacific's historical archive held maintenance records, operational logs, and engineering correspondence from the big boy era that documented what had been done to these locomotives, but not always why, or what the experienced judgment of a skilled steam machinist would have identified as significant that the written record treated as routine. The living link to operational big boy knowledge was thin by 2013. The youngest men who had worked on these locomotives as journeymen in the late 1950s were in their mid-80s. Some were still available for consultation. Their knowledge was specific, detailed, and irreplaceable. The kind of knowledge that comes from having solved particular problems with particular machines under operational pressure, and that does not transfer completely through any medium except direct experience. Ed Dickens and his team sought these men out and consulted them throughout the restoration. Conversations about specific systems, specific problems, specific aspects of big boy maintenance that the written records did not fully capture became part of the restoration's knowledge base. The information gathered through these conversations was documented, written into the maintenance procedures that would govern the restored locomotive's ongoing operation, in a way that the original knowledge never had been, because the original workforce had not anticipated needing to transfer their knowledge to a generation that would have no other access to it. The steam preservation community outside Union Pacific, the heritage railways, the museum restoration programs, the volunteer organizations that maintained operational steam equipment in Britain and elsewhere, also contributed to the knowledge recovery. Britain's mainline steam preservation program, which had maintained a small fleet of operational vintage locomotives since the 1970s, had accumulated practical experience with the specific problems of operating large steam locomotives on mainline track, using a workforce that had learned from documentation rather than from direct apprenticeship. The parallels between the British preservation experience and the big boy restoration were not exact. British locomotives were smaller and differently constructed, but the problem-solving approach that the British program had developed was directly applicable. The boiler testing that preceded the locomotive's return to steam was the regulatory milestone that everything else in the restoration had been building toward. Federal Railroad Administration regulations governing the operation of steam locomotives on American mainlines require that the boiler be hydrostatically tested at 150% of its designed working pressure before being placed in service, and that the test be witnessed and certified by an FRA qualified inspector. For number 4014, whose designed working pressure was 300 pounds per square inch, this meant pressurizing the boiler to 450 pounds per square inch with cold water and holding that pressure for a specified duration while inspectors examined every accessible surface for leaks, deformation, or other evidence of inadequate integrity. The hydrostatic test passed. The boiler that had been sitting in Pomona's park for 54 years, repaired, retubed, and inspected by Union Pacific's restoration team and independent inspectors, held 450 pounds per square inch without failure. The certification that followed was the legal authorization that converted number 4014 from a static artifact into an operational steam locomotive. A document whose significance was understood by everyone present at the test, in a way that photographs and descriptions cannot fully convey. The first fire in the firebox, the moment when coal was loaded into the mechanical stoker's tender and the firebox was lit for the first time in 60 years, produced a response from the locomotive that was simultaneously expected and arresting. The boiler began generating steam. The pressure gauge, new, fabricated to the original specification, installed where the original gauge had been removed decades earlier, began rising. The sounds of a large steam locomotive warming up, expanding under heat, releasing the condensation that accumulates in cold pipes and cylinders, resumed in the Cheyenne steam shop after a 60-year silence. The first movement under power was conducted in the shopyard, controlled, slow, with the entire team present, with every system monitored for the anomalies that first operation after a major overhaul inevitably produces. Valves that had been set from drawings rather than from direct operational experience were adjusted. Steam connections that had been reassembled from documentation were verified. The mechanical stoker's coal delivery rate was calibrated against the boiler's steam generation response. Over several months of testing, the locomotive's systems were brought into the operational condition that the restoration's goal required. Each test run extended the distance and duration of operation. Each run produced data about the locomotive's behavior that was incorporated into the maintenance procedures and operational guidelines that would govern its ongoing service. By early 2019, number 4014 was ready for the mainline. The first mainline run, in May 2019, carried Union Pacific executives and invited guests across Wyoming on a route that overlapped with the original Big Boy's operational territory. The communities the train passed through had been notified in advance. People came out, not in the polite numbers but attend routine railway excursions, but in the unplanned, spontaneous, self-organizing numbers but attached to events that people recognize as singular. In small Wyoming towns, where the population might be measured in hundreds, the trackside crowds numbered in the thousands. People drove hours from surrounding areas to stand beside the track for the 30 seconds that the locomotive would be visible as it passed. They brought children who would remember it. They brought cameras. Some of them brought tears, which surprised them. They had not anticipated but the sound and presence of a working big boy would produce an emotional response but they could not fully control. The locomotive itself behaved as its restoration team had intended. The boiler maintained pressure. The mechanical stoker delivered coal at the designed rate. The running gear, rebuilt from the disassembled components and replacement parts that the restoration had produced, operated without the anomalies that had characterized the first test runs. The exhaust note, the characteristic chuff of a four-cylinder simple expansion locomotive with two engine units exhausting in sequence, filled the Wyoming landscape with a sound that none of the people present had heard before from a locomotive that was actually moving. The operational data from the 2019 tour was incorporated into the maintenance procedures that govern the locomotive's ongoing assignments. Union Pacific operates number 4014 on periodic excursion tours, typically annual or biennial events that route the locomotive through different parts of the system, always with the logistical complexity that a working steam locomotive requires. Coal supply, water supply, specialized crew, advanced track inspection, and the coordinated effort of a mechanical support team that travels with the locomotive throughout its tour. The restoration of number 4014 raises a question that the steam preservation community has debated since the project was announced, and that the operational results have not entirely resolved. What does it mean to restore a historical machine to operational condition, and what is preserved in the restoration that would not have been preserved in a museum display? The answer that the technical record supports is specific. A static display preserves the physical form of a machine, its dimensions, its materials, its mechanical configuration. It does not preserve the operational knowledge required to run it because that knowledge does not reside in the machine, but in the people who have operated and maintained it. When the last generation of big boy operators retired in the 1970s, and when the machine stood static for another 4 decades, the operational knowledge did not disappear entirely. It was partially captured in documents, partially transmitted through the heritage steam community, partially reconstructed through the restoration process itself. But it was not preserved intact, and a significant fraction of it was recovered rather than maintained. An operational restoration preserves the machine in a different sense. It produces and continuously regenerates the institutional knowledge required to operate it. The Union Pacific Steam Shop, as a result of restoring and operating number 4014, now contains engineers, machinists, and crews who understand the big boy's specific systems not from documents, but from direct experience. They have solved problems with this specific machine. They have calibrated its behavior against their own physical experience of operating it. They have accumulated the kind of knowledge that can only be generated by doing, and that was lost for 60 years, not because no one wrote it down, but because no one was doing it. That knowledge is fragile in the way that all institutional knowledge is fragile. It resides in people who will eventually retire, in a workforce that must be continuously renewed if the knowledge is to persist. But it exists now, in 2024, in a form that it did not exist in 2013. The restoration created it. The ongoing operation sustains it. The story of number 4014's restoration sits at the intersection of engineering and institutional memory in a way that the other machines in the series do not quite reach. The T1, the Niagara, the Q2, the John Henry, the 242A1, all of them were lost before preservation was possible, before the decision to preserve could be made, or before the resources and institutional will could be assembled in time. Their stories are stories of absence. What the technical record says was possible, what the physical evidence no longer exists to demonstrate. Number 4014's story is different. It is a story about what happens when the decision to preserve is made early enough, and the resources are sufficient, and the institutional will is sustained long enough to complete the work. The result is not a perfect historical artifact. The restoration introduced contemporary materials and methods in places where the original materials and methods were not reproducible. But it is a functional machine, operating on the mainline, demonstrating in physical real time what the historical record describes in words and numbers. When number 4014 passes through a Wyoming town on one of its periodic tours, the people standing at trackside are experiencing something that is simultaneously historical and present. A machine from 1941 operating in 2024, maintained by knowledge that was partially lost and partially recovered, on rails that carry freight every day by different means. The gap between the historical and the present is not concealed by the restoration. It is the restoration's most significant product, the demonstration that the gap can be crossed, that what was lost can be partially recovered, and that the decision to attempt the recovery, made early enough and pursued with sufficient resources, produces a result that no museum display can replicate. The locomotive was dead for 60 years. The men who brought it back spent 7 years recovering what those 60 years had cost. What they produced, the sound, the presence, the operational reality of a working big boy on the main line, is available to anyone standing at the right place along the Union Pacific's Wyoming territory when number 4014 is on tour. The ticket is free. You just have to know when to be there.